Ladies and gentlemen, in my Physics 4A class, hello, I hope you do well, and we all together will overcome on this situation. We are in chapter 8, so I'm going to talk about circular motion. Uh, Chapter 8 is about dynamic of circular motion. So if you remember, we had kinematic of circular motion. It was in chapter 4, but in chapter 4 I didn't do lecture about that, so I told you that I keep all circular motion in the same time I will do lecture about it to not be confusing you. So that's why I have all circular motion today. I'll go over it in chapter 8. So I started from chapter 4 and then I will go over dynamic. What we need to know from beginning of circular motion, it's first of all, I'll go over kinematic of circular motion, then it will be dynamic of circular motion. The topics that we need to know, the first one is radian. What is definition of radian? The second one is called arc length, which we showed by S. Radian also we showed by RAD. Third one is called tangent velocity, which we showed by VT. So please don't get confused terminal velocity with VT, tangent velocity. The next topic will be angular velocity, which is called omega. And then tangent acceleration, which we showed by AT, index T. And then it's angular acceleration, it's all alpha. And then we will go over equations in uniform and non-uniform motion, and finally I will go over dynamic of circular motion. So what we see here, we see tangent velocity, tangent acceleration. So these two, which they are tangent, guys, we learned them actually in chapter 2, 3, and 4. So what is velocity means is change in position divided by time, distance divided by time. It was velocity, so this is tangent velocity. I'll tell you what is tangent means. Tangent acceleration, what was acceleration? It was change in velocity divided by time. So this acceleration is same as what we learned, this velocity and this tangent acceleration, tangent velocity, same velocity, same acceleration as we learned it in kinematic on linear motion, linear axis. And then number 4 and number 6, it says angular velocity, angular acceleration. What is the angular means? Angular means is it's at the angle where the angle changes. It means is circle at the center of circle. So when it says angular velocity, that means it's velocity at center. When it says angular acceleration, that means it's acceleration at center. Okay. Now, here, first of all, I go over definition of radian. What is definition of radian means, guys? Definition of radian is this. Imagine you are at point A and then you go from point A to point B. So this one, which is from A to B, it's called arc length. Now ask this question. Is the radius of the circle, this r, is same with the length of arc AB? Now you can see actually, is the length of radius equal with the length of AB? The answer is no. Why? Because I see this is like 2.5 centimeter. This is just like 8 millimeter. You know what I mean? So this is like 2.5. This is 25 millimeter. This is just 8 millimeter. So it's not. Okay, let's go a little higher. So go from point B to C. Go from A to C. Now ask this question. Is the length of R, if the length is the length of radius, equal with the length of AC? Answer is yes, no. No, not yet. This is 25 millimeter. This is 20 millimeter. Okay. So let me go a little higher. Go to point D. Go. Go from A to D. Now ask this question. Is the radius length, is the length of radius equal with the arc of AD? Is the equal with the length of AD? Oh, let me see. This is 25 millimeter. Yes, this one is 25 millimeter too. Therefore, answer is yes. And I will say, yes, AD is equal with R. The answer is yes, they are. When we say the angle of, the arc length is equal with radius, then at what angle? That angle is called radian. So what is definition of radian? It says at certain angle, length of arc is equal with length of radius. That angle is called 1 radian. That angle is called what? 1 radian. It's almost 57.3 degrees. So when your angle becomes 57.3 degrees, now we go by degrees, that is called 1 radian. The length of arc is equal, the length of arc is equal with the length of radius. Excuse me. Let me know if you have any questions, please email me. Now, what is pi? As we know, pi is 3.14 radians. It's a lot of history of pi. 3,500 years ago, Chinese actually, they found it as 3.12. So this was by Chinese. Egyptian mathematician, they found it 3.132. And then Assyrians mathematician, they found it 3.1, let me erase this. 3.1, very close, 39 something. But now today we know that pi is 3.14 plus 5 millionth digit, correct? We accept it as 3.14. So the unit of pi is radian. When we say pi over 2, what is the unit of pi over 2? It's radian, correct? Which that is equal with 90 degrees. Why do we say it's 90 degrees? Because of that. Because 3.14, 1 radian is 57.3 degrees divided by 2. If you do it, this answer becomes 90 degrees. Make sense? So same thing here. How do we say that pi radian is 180? It's because of this. Pi is 3.14. 1 radian is 57.3 degrees. If you do multiplication of these two, you will get almost 180 degrees. But what is definition of pi? If I assume this is a circle and this one is the radius of r, this works, guys, for any circle, for atom, for sphere, for basketball, for stars, for Jupiter, for planet Earth, for Saturn, for all circles, it works well. I did it several times. Like if you have, let me see, can I find a circle here? I had circle, yeah. Imagine this is circle, correct? Around this circle, just put one string completely, then remove that string, then measure the length of string. So the length of that string, which is the length of circle, if you do it, divided by 2 radius, which 2 radius is diameter, it will give you one ratio. It will give you one constant value. This works for any kind of circles. Small circle or big circle. That is constant. So pi is this. So what is the circumference of circle? C equal 2 pi r. Now, what is definition of arc length? Watch, guys, it's very important topic, this section. You will use it a lot in physics 4b. So if I go from point A to point B, this is my arc. So this arc from A to B we showed by S. It's called arc length. And the unit of length, you know its length, it's meters, correct? Therefore, what is S? The length of arc, or AB, it's R times times this angle. Radius times angle, but not by degrees, by radian. Be careful. Your angle is by radian. Therefore, theta becomes S over R. So guys, radian is not the unit in part of 7 major quantities. Radian is inside length. Radian is inside the length. That's why the unit of length is meter. Radius is meter also. So this equation is correct because your left side has the unit of meter. The right side also has the unit of meter. Don't say meters radians because that radians is inside meter, inside the radius. So S is equal with R theta, or some book also instead of S it says L. So L is equal with R theta. Okay. Now, this is called arc length. What is tangent velocity? We showed by Vt. Look guys, let's say I do have a circle. Let's say I do have a circle. Here what I have. Let's say this is a circle, correct? So this one is a circle. Let's assume it's circle. Now if you open it, it becomes what? One straight line. If I make it circle, it's circle. So guys, watch. Circle, straight line. Circle, straight line. What does that mean? So here I do have a circle. If I open this circle, it will be what? Straight line. Now when straight line, a car goes on it, a car goes by speed or velocity of v. Let's say it's constant. If I open this circle, the length of the circle becomes equal with what? With circumference, correct? So it is circumference actually. Let me see. Now, so when a car goes on one line, what is its speed, its velocity? It's v. Yes. Now you make this line as a circle. As a circle. So what is happening? Your car will go on the circle, correct? The velocity that car goes on the circle by that velocity, by that speed, it's called Vt. And you see it's same as this. So this is same as Vt. But we didn't put this tangent in chapter 2, 3, 4. Why? Because it wasn't circular motion. It was linear motion. So tangent velocity, it's same velocity as object has it on one line. It's called tangent velocity. Why? Because it is what? It is tangent on the circle. Don't forget this. It is tangent on the circle. And as this velocity unit is meters per second, we learned that in chapter 2, 3, 4. This velocity, which is tangent velocity, is meters per second. Why? Because velocity is distance divided by time. What is the distance here? It's length of arc. It is length of arc. So we can say Vt is S divided by what? By time. Correct? So tangent velocity is length of arc divided by, so it's length of arc divided by time interval. Correct? That's why it is meters per second. So it's velocity on the circle or on the circumference. Now, the next topic number 4, it's called angular velocity. Okay? Watch guys, what is angular velocity? Let's say this is a circle, correct? And what I am going to have actually, I know that we always have velocity on the circle, correct? Velocity on the circle. Okay, is okay. So this is Vt. This is Vt. Let's say Vt is constant. Now, we know that tangent velocity Vt is what? Is distance divided by time interval. Okay. Now, we know that S is equal with R theta. Or I showed it by big R. Let me write this one big R. It's okay. Therefore, delta S becomes what? Can I write it? It's R times delta theta. Why? Because R is constant. The radius of circle, of course, it is constant. Correct? So this is radius. So, but angle can change because angle can be uh, smaller or bigger. Therefore, instead of delta S, I can put R delta theta divided by delta T. All right? What is delta theta divided by delta T? Pay attention. So I want to see actually what is this guy? What is that guy? Correct? Change in angle. So this is change in angle, correct? Divided by time interval. Yes or no? Oh, okay. It's change in angle. What is angle? It's radian, correct? What is time interval? It's second. Oh, so this is very, very similar actually to this equation. Change in, this is change in length, this is change in angle, correct? Remember, angle and length, they have relationship. S is equal with R theta. So this is very similar to this equation. This is change in angle divided time interval. So let's call it angular velocity. Let's call it omega. Therefore, what is omega, guys? It's delta t theta divided by delta t. Correct? So Vt becomes equal with R omega. Put the vector arrow on it because velocity is vector quantity. Omega will be vector quantity too. So what is omega means? It's by what, pay attention on this definition, by what rate, angle, at center changes, rate of change in angle per time, or rate of change in angle, it's called omega. Guys, when we say rate, what is the rate means? It's that quantity divided by time. So when we say rate of change in angle, that means it's change in angle divided by time. Let me show you one important thing. Look at on this drawing. Look, your angle changes here, correct? At the center. So by what angle, by what rate this angle changes, by what rate this angle changes at the center, that is called angular velocity we showed by omega. So guys, omega is at center of circle. Do not forget this, please. So where is omega? At the center of circle. What is the unit of omega? You tell me. Radians per second. What is the unit of omega? It's radians per second. Do not forget this. This velocity v is meters per second. This is radians per second. So very similar to each other, correct? That is called angular acceleration. Now, here what we have. We said omega is delta theta divided by what? Delta t, yes. Correct? Let's call it, as we have average velocity, let's call this one average angular velocity. So if we write this equation in calculus space, we are going to have omega is d theta over dt. As we had before, velocity is delta x over delta t, and then remember in calculus space we wrote it v is dx over dt, correct? We should have vector arrow on it. And here too. All right. Therefore, we wrote this equation that, guys, dx is v dt, correct? And then what we have, we wrote this x can be equal with integral v dt plus x naught, which I called it actually, if you remember, uh, I called it further equation, correct? So here, what can I write? I can write actually theta d theta is omega dt, correct? So let's put vector arrow on it. Therefore, I can write theta is integral omega dt, this is time, plus what? A constant. Very important equation is. Okay. So this is called angular velocity. As we had here, displacement displacement is area under graph velocity versus time. Here we can say displacement in angle or angular displacement which it is theta, it's area under graph velocity versus time plus theta naught. Let me write this one angular. Very important equation. Now, let's go on tangent acceleration. Again, imagine guys, this is circle, a car goes on the circle, correct? A car goes on the circle. So what I am going to have actually, if, if Vt is not constant, if tangent velocity is not constant, therefore I am going to have an acceleration on the circle. What is that? Therefore I am going to have an acceleration on the circle, which is called what? AT. Come on. Which is called AT. Correct? What is AT? It's here. It's AT. It's tangent acceleration. It is here. And of course we do have Vt. And of course we do have what? Tangent velocity. Therefore, what is tangent velocity equation? Of course it will be change in velocity divided by time interval. Okay? Now, in the previous page here, this is very important equation. What do we see? Vt is equal r omega. Okay, so I can write actually, because Vt is equal with r omega, r is the radius of circle, so I can write delta r omega divided by delta t equal r is constant, correct? So that will be delta omega divided by what? Delta t, correct? What is this delta omega divided by delta t? Pay attention. It is change, or let me write rate. Rate means divided by time. Rate of change in angular velocity. What is change in velocity divided by time? Oh, I call this one what? Angular acceleration. I call it alpha or alpha. Okay? Therefore, let me go by blue. Therefore, guys, what I have, AT is equal with what? R times alpha. What is alpha? It's delta omega divided by what? Delta t. Correct? Then what is the unit of alpha? Will be radians per second divided by second will be radians per what? Second square. Correct? Therefore, I can say this. Okay, alpha is delta omega divided by delta t, correct? So in calculus, I can write alpha is what? D omega divided by dt. Yes? Keep it very important equation. Put the vector arrow on top, please. So here I can write d omega is alpha dt. Yes? Therefore, I can say omega is integral alpha dt plus a constant, which is constant. Usually it's initial angular velocity. So what is delta omega is omega minus omega naught. What was delta v? It was v minus v naught. What was delta x? It was x minus x naught. What is delta theta? It's theta minus theta naught. So these two are equivalent. These two are equivalent. Therefore, we can say what? Omega is area under graph acceleration. Of course, must be angular acceleration. Angular acceleration versus time plus what? Omega naught. This is very important. So as we have father-mother equation, here we have also father-mother equation in circular motion. Okay? Now guys, so I don't want to derive equations because I did it already in chapter 2, 3, 4, but as we have uniform motion in chapter 2, we have uniform motion in circular motion. As we have non-uniform motion on linear motion, we have non-uniform motion in circular motion, which is called non-uniform circular motion. Therefore, as we have x equal v bar t plus x naught, here we have theta equal omega bar t plus what? Theta naught. So this is on linear motion, here in circular motion, correct? As we had what? V equal V bar, let's say, or let me write equations. As we had V equal AT plus V naught, here we are going to have omega equal alpha t plus what? Omega naught. As we had x equal half alpha, half at squared plus v naught t plus x naught, correct? Here we are going to have, instead of x, we have theta, half is half. Instead of a, it's alpha, t squared is t squared, v naught is omega naught, t is t, and instead of x naught, we are going to have what? Theta naught, which usually x naught and t naught, theta naught is 0. As we had v, it's ugly v, as we had v squared was equal with v naught squared plus 2a delta x, correct? Here we are going to have omega squared is equal with omega naught squared plus 2 alpha delta theta, okay? As here we had v bar is v naught plus v divided by 2. Average velocity is initial velocity plus final divided by 2. Here we are going to have omega bar is omega naught plus omega divided by 2. These equations, they are for non-uniform motion. This equation is for uniform motion. Okay, now we have uniform circular motion, non-uniform circular motion. Imagine you are on the circle and you put your car on cruise control with 40 miles per hour. You go around the circle with 40 miles per hour all the time, so your velocity is constant. You do not have acceleration, so that is called uniform circular motion. Now you are in the circle, but you push the gas. You increase, you decrease, you decrease, you increase. You push the brake, then you push the gas. So this is called non-uniform motion. You do have acceleration in this time, or deceleration. Okay? And more important, as we had father and mother equation, remember x was integral v dt plus a constant, correct? So let me put vector arrow on it. So here we are going to have what? Instead of x, it's theta equal integral omega dt plus constant, okay? Which you have to use boundary condition to find c. As we had here, mother equation was this: v equal, of course these are the function of time, integral a dt plus constant, correct? Here we are going to have omega equal integral alpha dt plus constant. Okay, so this is all about kinematic of circular motion. On my next video, I will go over dynamic of circular motion. Please learn these equations. These are very important. Oh, I forgot also this one, that uh, what very important. Vt tangent velocity is r omega, and at is r alpha. You see this? Who is making relationship between tangent velocity, between velocity on the circle with velocity at the center, radius? Who is making relationship between acceleration on the circle with acceleration at the center, radius? So Vt equal r omega, At equal r alpha. Okay. So practice again. On my next video, I will go over dynamic of circular motion, and chapter 8 will be done. So then I covered completely after I finish dynamic of circular motion. So I'm done with circular motion, kinematic and dynamic. Enjoy it. Bye guys.